Hey, calculus students, this is the last technique we're going to cover, and this is almost like a last resort is the way I look at this one. So if you've tried substitution, didn't work, you've tried partial fractions, didn't work, and you notice that you've got a product of two factors, and you'll see in the examples of what I mean by that, but any two functions that you've got multiplied by each other, okay? You could use integration by parts. Now, of course, we use substitution a lot on that, and it works almost all the time. But here's when it doesn't work. This is something you can do. So, usually when you got a product term, especially substitution, this technique comes from the product rule of derivatives. So I just wrote down the product rule again so you could see it. So the derivative of the first times the second plus the derivative of the second times the first. And then if we look at it the other way, like if I take the integral of this plus the integral of this, that'll equal our f of x times g of x again. Okay, so that's all I've done here. In this next line, I've said f of x times g of x equals the integral of those two things too, right? So working it backwards. So now, if you reorganize it, right? And it doesn't matter which one you choose to isolate. I chose to get rid of the g prime of x, f of x, but you could do it the other way around. It does not matter, okay? Because we're not even going to use these terms. I'm just showing you where this comes from. Because it's used on a product of factors, so we have to have a product of something to work ourselves backwards, okay? Now, I'm going to change the variables we use just for simplicity. So I'm going to start to use u's and v's, and of course du and dv, okay? And I'll show you that on the next page here. So, written in different terms, just because it's easier for the substitution method, because we will use substitution method for this, because it's a technique where we combine some stuff. So in this case here, if you're referencing from the previous page, I have substituted u in wherever there was a g of x and a v in for wherever there was an f of x. And of course, dv and du stuff comes into play. So this is the exact same formula as this guy right here, okay? Just written using different formulas. So now I've got steps. So let a term equal u and a second term equal dv. So that's how it starts. And you're going to see that there's no real right or wrong. Well, I shouldn't say that. There is a right or wrong or an easier way, but there's certain things that we always let happen first. And then we take the derivative of u to get our du, and we integrate the dv to get the v. So we'll have all four things that we need for the formula. And then we're going to substitute our values in, and we'll solve it. So now here's where the first tip comes in. If one of the terms is a power of x, so x squared, x cubed, x to the 1, doesn't matter. Let that be u. Unless one of the terms is ln x, I always let ln x be my u first, if there's a ln x in the question. And again, you'll see that in the examples. Now this is a pretty straightforward process or technique. I think this is a lot easier than partial fractions if you have to use it. We don't use it a whole bunch. Like I think I only give you about 10 questions. So you'll see here on the first example how simple it can be. All right. So you can see here, if you had this question x sine x and you tried to use substitution and you let u equal x, it wouldn't work. If you let u equal sine x, it wouldn't work. But I've got a product. I've got a function of x times a function of sine x. So now I have to decide, hey, I can use integration by parts. And Mr. Domenico said, let u equal the power of x. So here we go. I'm going to let u equal x. I'm going to let dv equal sine x. So the other function. Step 2 says take the derivative of u, so du equals 1, and integrate dv to get your v. So I integrate sine x, I get negative cos x. And then we just substitute those values into our formula over here. So I'll write this down. Maybe I'll write this down, right? So we started u dv. And again, you could have done v du, and then it's all the same. It didn't matter, okay? So u dv equals u times v minus v du. So that's the formula we're going to substitute all of our stuff that we figured out here into. So our u, this is always going to be the question. So x sine x, that's our u and our dv, And of course you can keep your dx there, of course, but I'm not too worried about that right now. And then we put u times v. So negative x cos x is right there, minus the integral of v, which is negative cos x, du, which is 1. So you could just put your dx there because it's times 1, so it doesn't change anything. So now the integral, or the question, of x sine x is equal to negative x cos x. And you can make this a plus, right? So the integral of cos x is sine x, plus the integral of cos x is sine x plus a constant. So you notice you don't touch this guy because it's just a u times v. So you just put those in place and you integrate the rest. So there's your answer, guys. It's more about substituting in what you figured out up here and then integrating that last integral. All right? Let's go do this one. Here's a perfect example where we got ln x. So if I'm following the tip, I'm saying u equals ln x without even thinking about it. My dv is going to be x. My du is 1 over x. And then my v is x squared over 2 when I integrate x. So now, when I go down and do the question, I get ln x, x ln x. And that just always equals your u value times your v value. So I'm going to it doesn't matter what order you write it in because it's multiplication. So I'm just going to write it like this. And we don't have to do anything with that. Like that part's done unless we simplify it later. So then minus the integral. And the integral is always the opposite of what you used in the first. And I always think u dv. So this is v du. So this is going to be x squared over 2 times 1 over x. And of course I will simplify that before I go any further. So I'll write that down in one more line. X ln x equals x squared ln x all over 2 minus the integral of x over 2. And now we can just integrate that last chunk. So the question of the integral of x ln x, which you can't simplify using substitution, over 2 minus 1/4 when you do the power rule, or the antiderivative rule, I'll call it. Add the exponent and divide by the 2. There you go. You get minus 1/4 x squared plus your constant. So you can see how it simplifies it a little bit. It's just busy work getting there, but there it is. Okay, next one. Again, we don't have a ln x in this one, but we've got a power of x, so I'm going to go back to my tip and let u equal x squared. I'm going to let dv equal e to the x. My du is going to be 2x, of course, dx. My v, the integral of e to the x, is just e to the x. Now, this one here, you're going to see there's a trick to this one. That's why I got the star here, just to remind myself, oh yeah, you're going to see a little trick. So we're going to substitute everything in. So here's my u dv equals u times v, so x squared e to the x, again, that part's done, minus v du. I'm gonna reorder that just because I don't like having that ex first. So e du, like so. Now, whoa, again, do the integral. Look at this. This is still a product of factors. So here's a little hint. If I try to do the integral of this using substitution, let u equal x or something, it's still not going to work. So I'm going to try by parts again. Okay, so I'm going to switch colors here. I'm going to go to green maybe. So I'm going to let u equal x, dv equal e to the x, du equals 1, and v equals e to the x. So now this is going to look like x squared e to the x equals, our x squared e to the x doesn't change. Now, remember, this is all its own thing here, okay? So I'm going to do it down low here so you can see it. So it's going to be the, I'm just going to take that minus 2 out. I'm going to put minus 2 here. So I factored this negative 2 out, so I'm only dealing with the x e to the x. So we've got our u dv equals uv, so x e to the x, minus the integral of v du times 1, correct? So now I'll just quickly go like this, x e to the x. The integral of e to the x is e to the x. So there is your answer to this guy. So I'm just going to take all this and I'm going to replace, here I'll circle it in yellow, the answer to this guy, right? So that, what we just figured out, is the answer. So minus 2 times x e to the x minus e to the x, like so. And now we can go and simplify that if we want. So the answer here, x squared e to the x equals x squared e to the x minus 2x e to the x plus 2 e to the x. And I'm getting squished in here. So all this is for that guy right there. Okay? Oh, I guess I need my plus a constant here. Plus a constant. There's the answer. So again, not crazy hard work. Just kind of trying to keep track of it all, right? Okay. So we still, substitution wouldn't work, so we had to try by parts again. That's why somebody might have the question, well, why can't you use partial fractions? Or how do you know? Well, partial fractions, remember, is for rational functions when you got division of polynomials. This isn't for the division. This is for multiplication of polynomials or multiplication of functions. Okay? There's the difference. Let's go do this last one. There's another little twist on this one. And these are very rare, but I like to show them just because most of your questions are like question 1 and 2, pretty straightforward. Okay? This one where you had to do by parts again is rare. And this one is definitely rare. You don't see this very often. You get a hit here right away. So I'm going to let you, oops, here, I don't like that green, so we'll go back to blue here. Let's let you, oops, I was using red, I guess. Let u equal e to the x, dv equal cos x. Now, how do I know? I don't know. I don't know what to let u equal in this case. I'm just going with u equals e to the x because I think it might work. And if it doesn't work, or if it's harder, and it might work either way, I would just go back and erase it and try it the other way. Okay, that's totally a trial and error thing. Or as you get more practice behind it, things just start to make more sense. So the integral of our cos x here is sine x. All right, so now let's go back. Let's place all this stuff in here. We got the integral of our u dv is equal to our u times our v, so e to the x sine x, minus the integral of v du and here again I see an integral product of two factors. It doesn't look like anything's gotten any easier here. So we're going to end up doing by parts again here. So again, I'll switch colors here. I'll let my u equal e to the x, dv equals sine x, my du equals e to the x, and my v equals negative cos x. Okay, so now when I go and I simplify this all here, let's go, we're going to have, I'm just going to do it without using the whole formula, writing it all out. So I got e to the x negative cos x minus the integral of our v, which is negative cos x. So I'm going to change this to a plus cos x. So it's going to be e to the x cos x. So again, I just changed that minus to a plus because it's a minus cos x anyways. So okay, so now when I go back in here, I got the integral of e to the x cos x equals e to the x sine x minus all of this stuff. So that's going to change this to plus e to the x cos x minus the integral, because I'm multiplying that negative right here, this negative right there, into this binomial. So it reverts it back, e to the x cos x. Okay, so now this one is over the top, you guys, but you just kind of keep going with it until it works, right? Well, now stop and look at this question. Look at both sides of the equal sign. And it's hard, but you got to recognize this and this are the same. So I am going to add this integral, e to the x cos x, over to the other side. So if I add that to the other side, I am going to have two integrals of e to the x cos x on the left-hand side. And it's going to equal e to the x sine x plus e to the x cos x, like so. And the only thing that we need to know is the integral of e to the x cos x. So now I'm just going to divide it 2 out, and we're done, right? There's our answer. I'll just put my plus a constant on the end, and you can see here that I'll box in our answer, right? And that is I don't know, years of doing it, but I'll say another tip here is if you notice the exact same integrals in a question like we did here, I'll put a big fat green star on this line where we ended up with two integrals that were identical, you can always bring them together and simplify them like we did. That'll make your life so much easier. It doesn't happen very often, but if it ever does, you can. Okay? So the other tip was, again, if you have another product of factors in your integral, you might have to go ahead and do it again if substitution doesn't work, or whatever rule you got to go with. So I know it seems abstract, but it works. Go with it. Try it. You got about 10 questions to do, and get her done.